Hi everyone. So we're on the QR homework. We call it QR homework because you always have the answers here. Oops, I wrote them right here. And your goal is to get to those answers, but this is trig and something different's happening on each of these, so I felt like it was best to explain it to you. Limits with trig functions, QR number 5, find the limit. To remember, so I have the proofs to these, but this is like what you have to have memorized. So limit as x approaches 0 of sine x over x is always 1. And you're like, wait, we're dividing by 0, but this is a proof called the squeeze theorem or the sandwich theorem, where we prove that it's 1. You can also just look at a graph. I have a proof of this. I don't know if I have time to show it to you on this video, but this is equal to 0, but it's a fun proof, so I hope if I have time we'll do that. Okay, you ready? Here we go. So right now, this does not match this, and our goal is to make it match. Now, this is x over x, sine of x over x. If this is the same, then the whole limit will equal 1. So right now I have sine of 3x. So for this to equal 1, I need a 3 here. So watch. You should get real mad at me, because you can't, am I allowed to just put a 3 there? No. What do you have to do? In order to legally put something in the denominator, you have to also put it in the numerator, right? Now, is that legal? Is that okay? Yeah, I just multiplied by 3 over 3, which is 1. Got that? Now, why did I do that? Because this whole thing now that it's sine of 3x over 3x, this is equal to 1. The limit, because of this. Why? Because of this. How come? But we also have a 3 up here, so times 3. So this limit is 1, and then we had a 3 here. So 1 times 3 is 3. That's it. That's it. Let me show you again. Just watch this time. So what we're going to do is I'm going to multiply this by 3 over 3 because I'm just multiplying by 1. And then I kind of like, oh, you lights. Then I kind of like to do this. Okay, do I have my sine of 3x over 3x? I do. So that's equal to 1. So I have 1 times 3 is 3. All right. These have different numbers, but the only thing that will get the sine of 2x over 2x is the only thing that will make this limit equal to 1. Now I already have an x there, and I have 3 that I really don't need, but I do need, what do we need here in order for this to go to 1? So this had to be sine of 3x over 3x, so I need this to be sine of 2x over what? 2x. Is there already an x there? Yes, so I'm going to multiply only by 2. How do I legally put that 2 there? I also have to put it in the top. Okay, so the next step is like where we rearrange stuff and make it look pretty. So I have a 2. I'm going to leave that 2 in the front. And then I have a sine of 2x. Now I want the sine of 2x to be over 2x so that all goes to 1. So what do we have in the denominator? I had a 3 times x times 2, and there's my 2 times x. So let's put that 3 here. In multiplication, you can move stuff around, right? So I'm just moving it around so it's pleasing to the eye. Now, I forgot my limit. You get the idea. It's practice. The limit of this is now what? What is the limit of this? Well, the limit of this is 1. So this goes to 1. Sometimes we like to do this. It's going to 1. So what do we have as our final answer? What do we have left over? We have 2/3 times 1. So answer there is 2/3. I like these. Okay, now we have sine of 5x over sine of 2x. Guess what? The reciprocal of this is also 1. So if you ever have the limit as x approaches 0 of x over sine x, will always equal 1 as well. So watch. Limit, watch. That's what you're doing. You're watching a video. Do I need to say that? What did I do? Nothing. I just wrote them I wrote this one over here and this one over here, right? Okay, I might need some more room. It's okay, we'll figure this out. I'd like a different color marker. What am I using here? Purple. So is the red okay? I'll use a red pen. Hi, what would make this go to 1? If we have sine of 5x, what do we need to put here? What do we need here? We need a 5x. How do I legally put that 5x in the denominator? I need to put it in the numerator, but I don't want it to get in my way, so I'm going to put it over here. Remember I said I need more room? Can y'all see that? Yeah, good. I'm in the window still. Okay. How do I get this to go to 1? It says sine of 2x. What needs to go here for this to go to 1? I need a 2x. Now how do I legally put that 2x there? I need to put it in the denominator also. So I have a 2x here. Okay, that's my setup. Now let's do the limits. Let's evaluate the limits. The limit of this is 1 times the limit of 2x over sine of 2x is 1 times, and then I have 5x over 2x. What does that simplify to? 5 over 2. Everyone okay? All right, all right. Oh my gosh, this isn't one we memorized. What are we going to do? You can always just plug in. So let's try plugging in. Cosine of pi over 2 over pi over 2. Don't worry. 0, pi, pi over 2, and the coordinate point here is 0, 1. And so the cosine of pi over 2 is 0. What's 0 divided by anything? 0. And that's okay. You can have 0 in the top, you just can't have it in the denominator. What the heck is this? Just kidding. I see this 3. What do you want to do with that 3? Should we factor that 3 out? We have some trig identities, and we all know this is a limit. Okay, 1 minus cosine squared. We need to know these are the answers. Hi, sine squared plus cosine squared equals 1, always. So 1 minus cosine squared equals sine squared, right? So I'm going to substitute that out. I'm wondering, like, should I use this? Or I'm going to go back and use the top one because I'm going to use substitution. They'll be good because it will do the proof. Here we go. Hi. Limit, we all agree we're doing a limit still, of 3 times sine squared x all over x. We okay? I substituted this out for this using this Pythagorean identity. Now watch what I'm going to do. I forgot. You're watching the video. You don't have a choice. What is sine squared? Do you agree it's sine times sine? What? Okay, so I'm separating the factors, and now we are ready to evaluate the limit. Why, you ask? Well, because we can't plug in 0 because that's a 0 in the denominator. But what's the limit of this? Do you see how we created that? We created a sine x over x. So the limit of that is, well, let's start at the beginning. Limit of 3, 3. Limit of sine x over x is 1. What do we do with this? Well, we just plug in, we evaluate. What is the sine of 0? Sine of 0. What is the y value at 0 radians? The y value at 0 radians is 0. All that work, and our limit is a messy 0. I challenge you to have your notes look better than me. Guess what? We have time for that proof. We're done with this assignment. We love calculus. It's really pre-calc, but you ready? Proof. Hold on, wait, I'm getting a piece of paper. Yeah, just find paper. Should have paper. Ready? Get set. Here we go. I'm going to multiply by the conjugate. The conjugate gives you a difference of 2 squares. Do I have to write the limit each time, you guys? That's what I struggle with. Do I have to write the limit each time? Or will you forgive me? It's just a quick proof at the end of the video. How do I even know you're watching it? I guess I don't. What's 1 minus cosine squared? Didn't we just talked about that, right? 1 minus cosine squared is sine squared. So I'm going to simplify. This is actually sine squared x all over x times 1 plus cosine squared. Now, just like I did before and on all of these, we're going to separate this. So we're going to say sine x times sine x, and then we have in the denominator, why am I going so fast? We have that. Limit. We have the limit the whole way. Okay, ready? What is the limit? Now we're ready to evaluate the limit. What is the limit of this piece? The limit of this piece is 1. So I have 1 times the sine of 0 over 1 plus the cosine of 0. What's the sine of 0? 0. What's 1 plus the cosine of 0? 1 plus what is the cosine of 0? It's 1. So now I have, now I'm off the screen. I have 1 times 0 is 0 over 1 plus 1, 2. What's 0 divided by 2? 0. Yep. So you just have to rationalize or do math to get that 0 out of the denominator. And then once you don't have a 0 in the denominator, that's okay. Then you can evaluate and you might have a 0 in the numerator. So this was the proof of that. And we're done with QR5. Should I keep going? Maybe that would be like a reward for the people who kept watching. What are the 3 things that need to be true in order for the function to be continuous? Those are in your notes. Is this piecewise function continuous at x equals 0? Explain using the rules of continuity. So you're going to plug in 0 here, and you get 2. And you plug in 0 here, and you get negative 2. So does the limit from the left equal the limit from the right? No. So discontinuous because the limit does not exist. This one, is this one continuous at 2? 2 squared is 4, plus 1 is 5. 6. The limit from the left equals the limit from the right. And there, it's defined at 2. Yeah? So this is continuous. Cool. We're going to do this in class. We're going to do this in class. These are fantastic, but you got to show work. And you know what? You're going to need more room for number 5. And don't just try and plug in the numbers. You're going to need more room for number 5. Okay.